This is what I call the timer regulator board. There are at least three major features or functions of this board. The original purpose for this board was to convert the 12 volt or greater supply voltage from the battery into the 5 volt and 3.3 volt supply voltages to the main controller board. However, there was a secondary feature that I added to this board when I included a microcontroller, and that was to be able to shut the system down because I needed to be able to conserve the battery voltage. Because, for example, was not necessary to keep the weather station powered up continuously 24 hours a day. The batteries will only last probably about 15 hours with a continual, if they transmit every few minutes. So, if, for example, if the system is only powered up for about 3 minutes once an hour, it would last several days without needing to recharge the batteries. And the benefit of that is that the average current consumption of the system would be much lower, and it would be possible to build a solar battery charger, a very small one that would just keep the batteries charged up. And with the average current so low, that would allow for a much smaller solar panel to maintain the charge on the batteries. What you see on this board here, there are three switching regulator circuits. This circuit right here, this circuit here, and this circuit here. And then we also have the microcontroller circuit right here. This circuit here, his sole purpose is to supply 3.3. This is a 3.3 1/2 amp circuit, very efficient. That's why he's a larger coil with this. And it supplies power to the microcontroller, the 3.3 by the control for the microcontroller. This circuit is never powered down because this processor here is never powered down. This microcontroller communicates through this communication port here to the main controller board. And the main controller board tells us when to power down to shut these two circuits off, and it also tells it how long to power down. So although this controls his own circuitry, he's still subject to the commands from the main controller board. Now these two, this is the 5 volt. I think it's about a 1 amp little switching regulator circuit, and this is a 3.3 volt, I believe it's 3 amp switching regulator circuit. I used these are from Texas Instrument, these switching regulator modules here, and using the data sheets I identified some basic components here, the capacitors and diode and inductor and so forth, that would match up for those controllers for the voltages and current that I needed. These two yellow wires here, these go from the microcontroller to what I would call the on-off pins or voltage inhibit pins that will shut this controller down. This yellow wire comes from here, this processor, down to this switching regulator module to turn the 3.3 off. This yellow wire right here goes down from the microcontroller to this switching regulator circuit to shut it down. And but the shutdown will always, this is programmed, it's all software driven to, by the commands. It's programmed to receive and respond to commands from the main controller board. So the main controller board can send a command to set it, telling it, okay, set your sleep counter for, an hour, and then and then then when this board receives a command from the main controller board to shut down, it will turn off these signals here or set them to the right polarity to shut these two modules down. Power output will be greatly reduced, may not go down to zero, but it'll go greatly reduced to where the main board will shut down. And after a certain, then during that sleep time, this processor will maintain its processing and actually be counting down. And after the timeout period is expired, it will turn these two voltages on. The main board will power up, and the main board will do its functions. Once it's done processing the weather data and uploading it to the website and so forth, the main control board will send a command telling it, this processor, to shut down again, and it shuts down again. That's basically all this thing does. It powers up, and when it's told to shut down, it powers down, and it does a count after the count. And now this processor doesn't have to have an external crystal, but because it's responsible for the timing, I added this little ceramic resonator here to help it have a much more accurate timing than would be if it used its own internal counter. I think it's got an RC type of a counter inside of it. Okay, so this is a preliminary discussion of this timer regulator board. Well, there you have it. I hope this video has successfully introduced and presented the types of things that I will be including in these videos.